Okay, unfortunately, I just figured out that for whatever reason, a large portion of the lecture that I just gave wasn't recorded. So I'm going to have to redo this, and I'm going to have to splice this in, so hopefully this all makes sense. So I think where we left off was that we had V equals V naught plus AT. So without going through a whole big long explanation, this is a great equation, but it doesn't involve distance. So if you have a velocity time graph that looks like this, and here's V naught and here's V, okay? If you go through here and you find this area underneath here, that's going to get you displacement. So one of the things that you can do is break this up. This is why I hate technology. Hold on. It's been a bad afternoon. Yeah, so here's this big, here, let me take you through this. I've already gotten drunk. This is what you all should have recorded, but my camera didn't. So here's this big graph. This is going to save me some time, actually. So the top half of this is going to be a triangle, base times height, 1/2 base times height. The bottom half is going to be V naught T. So what we're going to do is that the top half of that triangle is going to be my final velocity minus my initial velocity multiplied by time. And then I'm going to add that to the bottom portion of that rectangle, which is going to be V naught T. So this term here gives me V naught T. This gives me the top half, which is this triangle. Now, don't write this down. Do not write this down. Okay? We're just looking at the big picture. So then, out of this, what we're going to do is we're going to combine all of these terms. We're going to distribute it, we're going to combine. And this is the equation that you're going to have. Distance equals 1/2 V plus V naught times time. This is a cool equation. This equation is not on your equation sheet. Okay, listen to me. This is not on your equation sheet. You might want to write this one down. D equals 1/2 V plus V naught times time. Pay attention to the fact that you are adding this together. You are not subtracting it. Okay? So basically, if you look at this, we're to a certain extent just finding the average of two velocities. We're adding them together and we're dividing by 2. That's the other way that you can think of this equation. Again, this is kind of a cool equation, but it's not on your equation sheet. So here's how this would play out. So let's say that you're going from 5 meters per second and you're speeding up to 25 meters per second and it takes you 10 seconds. And you want to figure out how far you're going to go. Okay, all this is a plug and chug type thing. Oh, I'm going to take 5 meters per second. I'm going to add that to 25 meters per second. I'm going to multiply by 10 and I'm going to get 150 meters. What you cannot do is you can't take 10 times 5 and go, oh, I'm going to go 50 meters. You're speeding up this entire time. Now, here's how we're going to come up with the next equation. So this is where we're going. This is. I'm irritated that I lost all this. So here's this first equation that we had. V equals V naught plus AT. What we're going to do is we're going to take this V naught plus AT and we're going to put that into this equation. So this is why I came up with this equation, so you can see where the second equation is going to come from. So what I'm going to do is I'm going to go through a whole bunch of algebra. Again, do not write this down. Do not write this down. So I have 1/2 V plus AT plus V naught. If you combine your V naughts, you get 2 V naught plus AT. And then you're going to distribute the time, and then you're going to distribute the 1/2. So when you get done with all of this, you get distance equals 1/2 V naught T plus 1/2 AT squared. So this is what's on your equation sheet. They have it as X, okay? So here's what's going to be important, is that this, okay, involves acceleration. This equation does not involve acceleration. So one of the key things you have to look at is that, okay, do I have acceleration or do I just have my velocities? So based upon what's going to happen here, okay, that's going to determine what's going to happen in terms of your choice of your equations. So here's what you can also look at. This equation, and somewhere or another I mentioned this, and I'll just write it again. Distance equals velocity times time. Okay? Oh, there it is down there. Distance equals velocity times time is a great equation, but it only works when you have constant velocity. So if you're moving at 20 meters per second for 5 seconds, and if you were to draw that on a velocity time graph, this is what it would look like. A horizontal line, and you're going to make a rectangle across like this. So distance equals velocity times time, if you think about it in terms of a velocity time graph, is nothing more than an area equation. Displacement is your area, velocity is your height, here's the base of the rectangle. Okay, that's all it is. But you can only use this if you have a rectangle, because that's when you have constant velocity. So if you were to look at a situation where you're going to move 20 meters per second for 5 seconds, you're going to travel 100 meters. Okay? It's a great equation. Now, the next question is that can you use this equation in the same sense? Yes, you can. Because if you're moving at a constant velocity, you don't have this acceleration part. This drops out. The only thing you have is that initial velocity is 20 meters per second. Multiply that by 5, you're going to get a distance of 100 meters. Okay, so here's how this would play out. Let's say you have a car starting from rest. It's going to accelerate for 4 seconds, and you're going to travel a distance of 50 meters, and you want to figure out what's the acceleration. Okay? Now, if you are of the VDAT mindset, again, you don't have to do this, but this is handy because you're only going to have 5 potential variables. V naught, displacement, acceleration, and time. If you'd like to keep things organized and do this, hey, knock yourself out. Do it. You don't have to, but it's highly recommended. So, I know how far I'm going to go. I know my time. What I don't know is my acceleration. I beg of you, get in the habit of solving these equations first, and then putting in the numbers. Okay? And then put in the numbers. So in this situation, I'm going to take 2 times 50, I'm going to divide that by 4 seconds squared. Now look what happens with the units. I got meters divided by seconds squared. That's going to give me the correct units of meters per second squared. So I don't know the answer to that, I just made it up. So, and this is on the video that you're going to see next. So this is where this is going to take off, because then I started recording this again. So I realize this is going to be kind of convoluted, but here's the basic idea. At this point, you have 3 equations. V equals V naught plus AT. Distance equals 1/2 AT squared plus V naught time. And you also have distance equals 1/2 V plus V naught times time. This one is not on your equation sheet. My ping pong ball is gone. This is not on your equation sheet. All you're doing is taking the average velocity. That's it. Okay, so then this is going to take off from what you already know. I apologize for the jacked up sequence on the videos, but technology happens.